Welcome back. It's time for video 2 as we continue our study on Unit 2 for Math 109. So with no further ado, let's get to a share. Fire up the PowerPoint here. And we'll go from that slide right there. There we go. Big screen. All right, this is an if-then statement. For those of you who like fancy names, this is called a conditional. And unlike our first two statements, conditionals have a specific order. So the first statement, P in this case, is called the hypothesis. It's the if part. And the second statement, Q in this case, is called the conclusion. So some books say read this P implies Q. I kind of prefer if P, then Q. Big red down there. The only time the conditional statement is false is when the hypothesis is true, but the conclusion is false. So you can think of it this way. If you all do well on the test, then I will give all of you an A. Suppose just for a second that you all do well on the test, but I don't give you all an A. I failed my if-then. My if-then statement in that case would be false. So you'll get a false condition on an if-then if the hypothesis P is Q is true and the conclusion Q happens to be false. All right, so I've got a series of slides, and every once in a while I kind of think like I should do better on this. Suppose I'm running for an office, and here's my claim. If I'm elected, then minimum wage will rise. And I'm probably not the first politician who's made this claim. So for this example, P is the I am elected part. Q is there's a subsequent rise in the minimum wage. So if I'm elected, then the minimum wage will rise is my if-then statement. All right, case one. Both P and Q are true. I was elected. I did lead to a rise in minimum wage. So my given statement was true. I promised that if I was elected, this would happen, and in fact, it did. So in this case, when both P and Q are true, if P, then Q also happens to be true. Case two, I won the election, so P was true. But you know what? I didn't follow through, which is maybe the blight of a lot of politicians. Minimum wage did not go up. So my given statement that said, if I'm elected, then I will let subsequently lead to a rise in minimum wage came up false. I didn't do what I promised. So P was true, but Q was false. And this, my friends, is the only time that the conditional if P, then Q is false. If the hypothesis is true, but the conclusion is false. Now, these last two are a little sneaky. In these cases, the P is false. I didn't win the election. I wasn't elected. So basically, all bets are off. My statement can't be proven true or false because I wasn't elected. So as weird as this is to some students, in this case, the if-then statement is still true. It can't be disproved. I didn't win the election, so my statement was not false. Right? So I wasn't elected. I didn't violate my statement. So the if-then statement stays true. Last case, neither happened. I wasn't elected. The minimum wage didn't go up. But again, since I wasn't elected, all bets were off. Hence, my given statement was not proven false. All right, here's your truth table for if P, then Q. Again, P and Q, as you've seen them previously, the right side column, if P, then Q. Notice the only time you're going to get a false statement on that if then is under the situation where the hypothesis P is true, but the conclusion is false. Oh, that's lovely yellow text highlighting that. That's pretty cool. Okay, some varieties on conditionals. All right, again, I'm going to show them to you. We're not going to do a ton with them. I'm not going to ask you to write them, but your book makes a big deal about these. So here we go. And what you're going to see is some negations will sneak in and some orders are going to change. So the original conditional was if P, then Q. All right, so you see the arrow there, P implies Q. All right, so what are you going to do, Dale? Well, on converse, we just change the order of the statements. All right, so it's if Q, then P. So the order of who used to be the hypothesis and who used to be the conditional are interchanged. The inverse takes your original conditional and negates both. So what used to be if P, then Q throws negations in on P and throws negations in on Q. No change on who's who, simply negating the original hypothesis and negating the original conclusion. Contrapositive negates both and interchanges. So the contrapositive is the negation as it applies to the converse. So your author would like you to know the conditionals and contrapositives are always logically equivalent. That simply means they have the same truth tables. All right. Here's some variations for you to read. If the conditional says, if you are sleeping, then you are breathing, that's probably true. All right. Converse simply interchanges the two clauses. If you are breathing, then you are sleeping. Actually, that's not true. Plenty of you are breathing right now, and hopefully most of you are not sleeping. The inverse throws some negations into the mix. If you are not sleeping, then you are not breathing. Well, if you're not sleeping, hopefully you're paying attention to this PowerPoint. I do hope you're still breathing, so that statement's probably false as well. Last but not least, if you are not breathing, then you are not sleeping. All right, well, that's as morose as it is. I think that's probably a true statement, because if you're not breathing, you probably have passed away. So excuse my morbidity on contrapositive. A biconditional is read if and only if. So if and only if. So P if and only if Q, or Q if and only if P. And we're not going to get too crazy. Your book's got it in there, so I threw it in the PowerPoint. All right, some valid reasoning kind of thing. So you accept some hypotheses and you try to decide if the conclusion is valid based on accepting those hypotheses as being true. So the hypotheses for this example say all professors at Immaculata are good looking, and Del Furster is a professor at Immaculata. So we are agreeing to accept those two statements as true. The question then, it says, is it valid to conclude that Del Furster is good looking? All right, so a little Venn diagram to help us. So the big outside circle is all the good looking people in the world. And contained inside that big outside circle is the set of professors who reside at Immaculata. So those premises said that all professors at Immaculata were good looking. And that's kind of what we see here. Everything inside that little circle is also contained inside the big circle. And oh my, there's Del Furster. He just showed up. He is, in fact, a professor at Immaculata. And I do believe it is valid then for us to conclude that Del Furster is good looking. All right, so what we're going to ask you to do on this particular Venn diagram is describe the dot down there that represents Professor X as completely as you can. Please notice that Professor X doesn't appear to be inside any of the circles that are highlighted in this Venn. So Professor X doesn't appear to be a man, doesn't appear to have blonde hair, and doesn't appear to be an instructor of mathematics. So if you were to describe Professor X as accurately and completely as you could, looks like Professor X is a female professor, because everyone represented on this Venn is in fact a professor. So the fact that that person's outside the men's circle means that, okay, got a female, doesn't have blonde hair, and does not teach math. All right, takes us to our first assignment from Unit 2. So for assignment 2A, we'll be doing some problems from the book. You'll find them on pages 47 to 50. Again, you can do them on blank paper, notebook paper, whatever you like. Scan them out to PDF and pop them out to the inbox attached to assignment 2A. And we'll be back shortly. I believe that may wrap us for video 2. We'll be back soon with video 3 from Unit 2. See you then.